Greetings to all of you. In today's session, we are going to discuss about the intermediate chemistry, where the topics are covered with the international level of entrance examination chemistry questions, and the national level JEE Advanced, JEE Mains, NEET Chemistry will be discussed over here. Telangana and Andhra Pradesh EAMCET examination entrance previous question papers detailed discussion is also given. This session is also helpful for the people who are aspiring for the competitive examination. So this will be helpful for the entrance exam and the competitive exams as well. Let's go with the question number 1. Identify the IUPAC names of the following compounds. So in accordance with the IUPAC, what will be the chemical name of all these compounds we have to give it. So IUPAC is called the International Union of Pure and Applied Chemistry. It is the international standard which provided the names for these compounds in a standard manner. So in accordance with this IUPAC, the first compound is given that ester compound. Whenever ester is there, alkyl alkanoate will be the IUPAC name in general. So alkyl stands for shorter carbon chain, which is the methyl. Alkanoate means longer parent chain will be taken here. Number of carbons are 1, 2, 3. 3 carbon is a prop. Prop is the suffix over here. So here propanoate. Alkyl means methyl. Here alkanoate means propanoate. So that methyl propanoate is the IUPAC name of the compound number 1. Let's go with the second compound, where you can find the amide functional group over here. Whenever amide group is there, alkanamide is the IUPAC name. In alkyl, alkanamide will be given. So in case of this one, you can find the secondary amine over here. Secondary amine means if nitrogen bonded to 2 alkyl called secondary, 1 alkyl called primary, 3 alkyl called tertiary. Fine. Here it is the kind of secondary alkyl where you can find alkanamide is the general IUPAC name. Enalkyl alkanamide is given for secondary amides, where enalkyl will be 1, 2, 3. 3 carbon chain and the nitrogen, so that N-propyl. N-propyl is the side chain which is present on the nitrogen. And here alkanamide. How many carbons we have? 2 carbons are there. 2 carbons will be given with eth. So that N-propyl ethanamide is the IUPAC name of this compound. And next is about nitrile. Whenever nitrile is taken, we have to consider nitrile carbon also in the chain of carbon. So this is also the part of this carbon chain. So that 1, 2, 3, 4 carbon chain will be there, where we can find nitrile over here. So that alkane nitrile is the general IUPAC name for nitriles. Alkane nitrile means here 4 carbon chain, so that we have to mention butane nitrile. The name of IUPAC name of the compound is butane nitrile. Let's go with another compound where aldehyde is there and branch bromide is also there. Okay. The parent chain is the longest chain. We need to consider 1, 2, 3, 4, 5. 5 carbon chain, where carbonyl carbon also included in the number of carbon atoms. 1, 2, 3, 4, 5 carbon chain with aldehyde. Whenever aldehyde is there, general IUPAC name will be alkanol, AL. Alkanol will be given. It is the pronunciation, where bromo will be there on first, second, third and fourth carbon atom. 4 bromo alkanol. Alka means how many carbons? 1, 2, 3, 4, 5 carbons. So that suffix will be pentanol. Right. So here 5 carbon chain, so that we have to mention penta. And being it is aldehyde, NaL will be the terminal functional group name. So that entire name will be 4-bromopentanol. This is a way to represent IUPAC nomenclature of the organic compound. Each and every compound is assigned with its IUPAC nomenclature in accordance with the regulations which already predefined. Okay. And here another compound where you can find the ketone. Around this ketone, you have 1, 2, 3, 4, 5, 6 carbons. Always, in order to name the ketone, we have to give alkanone. The common name of ketone will be alkanone, where the carbonyl group is there, that carbon to be mentioned with its number. Okay. So here 1, 2, 3. On the third carbon, you can find this ketonic group. So that let me mention 3. and being it is the member of 1, 2, 3, 4, 5, 6 carbon chain, so that hexa will be the prefix. Okay, and the third carbon is resided with the carbonyl, so that we can say 3-hexanone is the IUPAC name of this compound. This is the way we can mention. Ester is given with alkyl alkanoate, amide is given with enalkyl alkanamide, and nitrile is given with alkane. Nitrile is the common IUPAC name for the compound. Whenever aldehyde is there, alkanol is the general name, and whenever ketone is there, alkanone is the IUPAC name of this compound. This is a way to mention IUPAC nomenclature. So question number 1, all the compounds got given with their IUPAC nomenclature. Let's go with the question number 2. What is the normality of 1 molar solution of phosphoric acid? H3PO4 is called orthophosphoric acid, whose molarity is provided to you. We need to convert into normality. Molarity and normality are the measure of its concentration, right? Molarity is taken as number of moles, normality is taken as number of equivalents. In order to give the number of equivalents, we have to go for the basicity of the acid or else acidity of the bases. Okay, in value matters over here in order to relate these two. Let's go with how normality and molarity are correlated. So phosphoric acid is given with P double bond OH, OH and OH, where you can find the basicity of phosphoric acid as 3. Basicity means number of replaceable H plus ions are called its basicity. How many are there? 3 hydrogens are there, so that this is the basicity of phosphoric acid is 3. 3 hydrogens are easily replaced. It used to give 3 H plus ions, so that we can say it is tribasic acid. Phosphoric acid, orthophosphoric acid is the tribasic acid, and the formula will be normality is equal to N into M. N means what? Its basicity. M means its molarity. Its basicity is 3 and the molarity is 1. So that 3 multiplied with 1, you will get normality as 3 normal. 1 molar solution of phosphoric acid is equal to 3 normal solution, because there is a relation between the formula of normality and molarity. Normality is equal to weight by gram equivalent weight, right? In order to convert normality into molarity, it can be multiplied with the parameter called ERN. So here ERN denotes its acidity or basicity. So simply we can say valency. Okay, here the valency of this tribasic acid is 3, so that 3 into its molarity is taken as 1, so that we can multiply 3 into 1. 3 normal solution it will be. So 3 normality is provided in the option number B. For question number 2, option number B is the right answer. Let's move on to question number 3. Here it is purely the problem. A solution is prepared by mixing 0.01 molar each of this H2CO3 is called carbonic acid. NaHCO3 is called sodium bicarbonate called baking soda, and Na2CO3 this is called sodium carbonate called washing soda, and this sodium hydroxide base it will be. So all these got mixed. One is carbonic acid, sodium bicarbonate, sodium carbonate and sodium hydroxide, all together mixed in 100 ml of water, and it is prepared for 0.01 molar solution. pH of resulting solution to be calculated. Here it is the question given from chemical equilibrium and pH of the solution. So this is very important question, where you can find the pH of the resulting solutions to be determined. The data provided is pKa and pKa1, pKa2 are provided. Acid 1 and acid 2 are provided to you. That is carbonic acid 6.37 and 10.32 values are provided. That means remole of 1H plus, remole of 2H plus ions are provided to you. So pKa1 denotes water, remole of 1H plus. pKa2 denotes remole of second H plus ion. So that pKa1, pKa2 of carbonic acid are provided, and the log 2 value is also given. That value is also provided to you. So by using this data, we need to depict what is the pH of solution. In order to get the pH of solution, the formula is pH is equal to pKa1 plus log of 0.01 by 0.02, because pH will be negative logarithm of H plus ion only. That's why we need to consider pKa 1 value over here, right? So in order to get that, here is one term provided to you. Within the equation, within the problem, they mentioned that all the solutions are prepared and each chemical is added, so that they are having 0.01 molar solution. So in this, you can find the 0.01 molar sodium carbonate. Sodium carbonate is present in 0.01, and another compound which is called sodium bicarbonate. How much it is given? 0.01 is given. But within the reaction mixture, we have one acid called carbonic acid, another base called sodium hydroxide. Whenever sodium hydroxide and carbonic acid got mixed together, sodium bicarbonate will be generated. Okay, so sodium bicarbonate already existing, that is 0.01 mole, and one got synthesized in situ, means within the reaction it got generated, that is another. So entire number of moles of sodium bicarbonate will be 0.02 now. The combination of sodium bicarbonate and sodium carbonate is said to be buffer solution. Buffer solution means salt formation, and its a weak acid is said to be a buffer solution that got prepared over here. pH is equal to pKa2 plus log of sodium carbonate by sodium bicarbonate will be taken, right? So here what we can say, Henderson equation is used for the pH calculation, so that we are using sodium carbonate by sodium bicarbonate. Fine. So pK2 value is provided as 10.32, and log 0.02 by 0.01 by 0.02, it will become log 2. So the value will become log 2, and the log 2 value is already with you. If you substitute, what happens? When the value is substituted over here, it will be 0.30. 10.32 minus 0.30 subtraction, you will get 10.02. pH will not have any units, so that need not to mention the units, and the solution is said to be a basic one. 10.02 will make the solution basic. 10.02 will be the right answer for this problem. So in this mixture, you are going to pick the pH of the solution by using the formula pH is equal to pKa plus log sodium carbonate by sodium bicarbonate concentration. Fine. So this is the way we need to go for the problem. And question number 4 is provided. The treatment of aqueous solution of 3.74 grams of copper nitrate with the excess of potassium iodide results brown color solution along with the formation of precipitate. Passing dihydrogen sulfide through this brown color solution gives another precipitate X. The amount of X in grams is atomic mass of hydrogen 1, nitrogen 14, oxygen 16, sulfur 32, potassium 39, copper 63, iodine 127 are provided. Okay. So this is the kind of problem which are related with the number of moles, right? Number of moles to be calculated. Whenever copper nitrate is treated with potassium iodide, the possibility will be, the reaction probability will be copper nitrate, potassium iodide. Copper iodide will be formed, and iodine aqueous solution will be formed. That is the solution. And the potassium nitrate aqueous solution will be generated. The precipitate formed is copper iodide. This will be precipitated as a solid compound. Iodine liquid will be generated, and potassium nitrate will be formed. Through this brown color iodine solution, we are passing dihydrogen sulfide gas. Whenever dihydrogen sulfide gas is formed through this iodine solution, that used to give, here is the another equation, iodine plus dihydrogen sulfide gives rise to elemental sulfur, and HI will be formed, hydroiodic acid will be formed, right? Here, these two equations are having some similarity. The extent of iodine formed in the equation 1 exactly is equal to extent of iodine consumed in the second equation, right? So that the number of moles of copper nitrate exactly is equal to number of moles of sulfur over here. Means equivalence of copper nitrate is equal to equivalence of sulfur. Okay. Number of moles of copper nitrate is equal to number of moles of sulfur. Moles are given by weight by gram molecular weight. So for copper nitrate, it is given as 3.74 grams of copper nitrate. 3.74 is the weight of copper nitrate. Molecular weight of uh, copper nitrate to be calculated by adding 63. Nitrogen is given with 14, can be taken twice, and oxygens are 6. 6 oxygens are taken. If you add all these, so that you will get the molecular weight of copper nitrate as 187, and X to be depicted, that will be elemental sulfur will be formed. So whose weight to be determined? Weight of the sulfur to be calculated. Molecular sorry Atomic weight of the sulfur is given as 32. Atomic number is 16. Atomic weight will be 32, can be multiplied with the 2. So if you go with this calculation, X can be predicted. X value is given as 0.32 grams. This is the way to solve the problem. The treatment of aqueous solution of copper nitrate and potassium iodide, when treated, iodine will be liberated. That iodine can be added with the dihydrogen sulfide HTS gas, foul odor gas it will be. And whenever it is added, the precipitate of sulfur will be formed. The amount of sulfur will be 0.32. Right? Let's move on to question number 5. So from the following compound, the one which contains both sp and sp2 hybridized carbons. Here 6 compounds are provided to you. Among the 6 compounds, you need to depict how many compounds are having sp and sp2 hybridization both in a single compound. So in order to understand the hybridization, first of all, we have to go with a fundamental rule that whenever carbon is in contact with triple bond, always that carbon will be sp hybridized. Any carbon with a double bond, always it will be sp2 hybridized. Any carbon with only single bond around that, that will be sp3 hybridized. Based on this data, we need to identify which carbons are sp, sp2 and sp3 hybridized. Here if you see nitrile, this is called a nitrile bond. Carbon triple bond nitrogen called nitrile. So that nitrile or carbon is having sp hybridization, so that this sp hybridization is clear. And here ch2 is there. Ch2 is having all 4 carbons, all 4 bonds around this will be single bond, so that here you can find sp3 hybridization. And carboxylic acid, if you see the carboxylic acid, where it is, carboxylic acid is there, where carbon is accompanied by sp2, because it is bounded with the double bond. Whenever double bond is there around the carbon, you can find that carbon is sp2 hybridized. So within the compound number 1, sp is there, sp3 is there, sp2 is also there. So it is the part of the problem answer they are asking for. Option number 1 is the correct answer only. Let's go with the second one. In the second compound, all the carbons are bonded with the triple bonds only. 3 carbons are triple bonded. So the 3 carbons are only sp but not sp2. It will not be included. So option number 2 will be excluded. Let's go with compound number 3. Compound number 3, here it is. This is called a cumulative double bond. Continuous double bond is present. That is called a cumulative compound, where the CH2 carbon is having sp2, being it is bounded with the double bond, and this terminal carbon also with the double bond, so that first and third carbons are sp2, but here the second carbon having double bond both the side, it will be added with sp hybridization, so that this is a compound. This is the compound number 3, where you can find a cumulative double bonds over here. sp2 and sp will be there. This is also included in a answer. Option number 1 is included. Option number 3 is also included. Let's go with the compound number 4. Benzene ring with the carboxylic acid called benzoic acid. The name of compound is benzoic acid, where all the carbons of the benzene ring are sp2 hybridized in general. Carbon containing benzene rings are sp2 hybridized, that is well known, right? So that we can say sp2 carbons are there. And moreover, carboxylic acid carbon is also sp2. All carbons are sp2, so that we are not the, this compound 4 is not the part of sp2. Let's discuss about compound benzene nitrile. When benzene is there, all the carbons of benzene are sp2. That is very clear. When you go with this nitrile, carbon is possessing triple bond, so that sp hybridization is also there. sp2 followed by sp, we can say it is also the part of sp2. 1 is included, 3 is included, 5 is also included as well, right? And let's go with another compound called uh, amide. This is a kind of amide compound. So in this amide compound, we are having benzene ring, so that it is said to be a sp2 carbon atoms all. And this compound is having double bond O. When double bond is there, this carbon is resided with the sp2 as well. So that all 6 carbons, sorry, all 7 carbons of 6th compound are sp2 only. So that only option number 1, option number 3, option number 5. 1, 3 and 5 are the part of 1, 3 and 5 are the part of sp2 hybridization. This will be the correct answer. Let's go with the last question of the session. This is the part of organic chemistry where 1-chloro-3-methyl butane on reaction with metallic zinc and dilute hydrochloric acid gives a dash as the measure product. Here the compound is haloalkane and it is treated with metallic zinc. When zinc is added, it will insert it in between, so that dilute hydrochloric acid, it is a kind of acid treatment, so that zinc chloride will be removed, we will get the alkane. Haloalkanes will be converted into alkanes by means of zinc and hydrochloric acid treatment. Let's see what will be the mechanism. When the compound 1-chloro-3-methyl butane, this will be the starting material. Upon treating with metallic zinc, zinc will be inserted between carbon and chlorine and able to give the organometallic compound zinc chloride. This organometallic compound further involved in the reaction with dilute hydrochloric acid. This is another reagent we are adding. Whenever hydrochloric acid is added, zinc will accept the chlorine as and removed as zinc chloride. ZnCl2 will be eliminated and the remaining H plus will be added over here, so that it will be converted into isopentane. Isopentane simply given with the IUPAC name 2-methyl butane. The final product will be 2-methyl butane by taking zinc chloride as a byproduct. 2-methyl butane is provided in the option number 1. Option number 1 is the correct answer for question number 6. This is the mechanism of alkane synthesis. Okay. So by this we completed all 6 questions of the session. Hope this will be very much helpful for your preparation either towards any entrance examination or competitive exam as well. I'm requesting you to kindly like my video, comment over there and share with the aspirant whoever preparing for the similar examination and subscribe the channel. Thank you very much for your patient listening. Thank you one and all.